Is your application crawling because of a sluggish database? Let's unravel common database performance bottlenecks and learn how to fix them. Whether you're using MySQL or Postgres, this video will help you turbocharge your database performance. Slow queries are often the main culprits behind database slowdowns. Enabling slow query logging helps you catch them. In MySQL, you can enable the slow query log by adding the following to your configuration file. This setup logs queries that take longer than 2 seconds. In Postgres, set the following in your PostgreSQL configuration file. Now, slow queries will be logged for your analysis. Imagine your e-commerce app is slow during checkout. By enabling slow query logging, you discover a query taking 5 seconds to fetch product details. Identifying this slow query is the first step toward optimization. To understand why a query is slow, use explain to see how the database executes it. This command shows whether indexes are used or if a full table scan occurs. If explain reveals a full table scan on a large orders table, consider adding an index on customer_D to improve performance. Add an index, applicable to both MySQL and PostgreSQL. Now the query uses the index, reducing execution time from seconds to milliseconds. Indexes speed up data retrieval, but can slow down write operations. Here are some best practices for indexing. Index columns frequently used in where, join, or order by clauses. Avoid over-indexing to prevent slow insert and update operations. Use composite indexes wisely. The order of columns matters. For queries like following, create a composite index. This speeds up queries filtering by both customer ID and order date. Default database settings may not be optimal for your workload. Adjusting configurations helps you utilize your hardware efficiently. In MySQL, increase the buffer pool size in your configuration file. This allows MySQL to cache more data in memory. In Postgres, adjust memory settings in your configuration file. These settings help Postgres handle more data in RAM. With insufficient memory allocation, your database relies on disk input/output operations, slowing down queries. By increasing these settings, you reduce disk reads and improve performance. Too many open connections can overwhelm your database. Managing connections ensures stability and optimal performance. Monitor active connections. Regular monitoring helps identify connection issues. Set connection limits based on your server's capacity. In MySQL configuration, add following. For Postgres configuration, do this instead. Implement connection pooling to maintain a steady number of open connections, improving stability. Use tools like pgbouncer for Postgres or ProxySQL for MySQL. A spike in user activity can exhaust available connections, causing errors. Connection pooling helps handle high traffic smoothly, preventing downtime. Optimizing your database involves several key steps: identifying slow queries, understanding query execution plans, applying effective indexing strategies, tuning database configurations, managing connections efficiently. Start applying these tips today to boost your database performance. If you're looking to further optimize your database workflows, check out our previous video on streamlining MySQL access in Kubernetes. Don't forget to like, subscribe, and share this video. Happy optimizing!